All right, so here's the video to finish out our discussion on vectors from 9.4. So if a vector represents the speed and direction of an object, we call it a velocity vector. If a vector represents the direction and amount of force acting on an object, it is called a force vector. So you really want to look at the words. This will be particularly important for word problems, of course, to decide, do I have a velocity vector or a force vector? When we're looking at vectors, we can also write the vector v as the magnitude of the vector times the cosine alpha I plus sine alpha j. And here alpha is back to being an angle and is the angle that is between the x-axis and then the direction of the vector. So make sure you write this down, that v is the magnitude of v times cosine alpha I plus sine alpha j. So let's try that a couple times before we head to word problems. We're going to write the vector v in the form ai plus bj given the magnitude v and the angle alpha it makes with the positive x-axis. So our first case, we have the magnitude of v is 8 and we have our angle is 45, and let me write a little degree in there. So to write our vector v, we're going to do the magnitude, which is 8, and then we're going to have cosine of 45, and that's I, plus sine of 45j. So we started with a nice one. Cosine of 45 is the square root of 2 over 2. Hopefully that's one that you remember. Sine of 45 is also square root of 2 over 2. So we're going to go ahead and distribute that 8. So I have 8 square root of 2 over 2, I, and then again 8 square root of 2 over 2, j. Simplify because you can. So 8 over 2 is 4, so I have 4 square root of 2, I also have 4 square root of 2, j. Now we have our vector expressed in the form of ai plus bj. Let's do a second one. So same kind of thing, that we are going to write the vector in the form ai plus bj. This time we're given a magnitude of 25 and an angle of 330 degrees. So we can write v is equal to 25 times parentheses cosine of 330 I plus sine of 330 j. Right. Important to kind of think about before you go to your unit circle or however you're going to do this. 330 is all the way over here, over into the fourth quadrant. So when I'm looking, cosine is positive, but sine is negative. So you want to make sure you have the correct sign, S-I-G-N, when you're looking at this vector. All right, so keep the 25 for now. And then however you're coming up with what the cosine is, cosine of 330 is the square root of 3 over 2. Keep your eye. But the sine, remember we said sine is negative, and it's actually negative 1/2, and we have j. This doesn't really simplify too much. We're just going to go ahead and distribute. So I have 25 square root of 3 over 2. There's I. And then I'm going to make that a minus 25 over 2. And there's j. And that's all you're having to do with it. So nothing special beyond that. It's just finding the sine and cosine and distributing the magnitude. Okay. So let's go on to actually talking about this alpha and finding the direction. So this one says I have v is I plus the square root of 3j. How this is helpful is when you're looking at it, there's a 1 there, so let's put a 1, and then square root of 3, which is a little bit less than 2. This is what we're looking at over here. So we want 1 over, we want square root of 3 up, so we can write that here, we can write that here. So if we're looking for this alpha of how much we went up, we've done this a bunch of times. So what would we use to figure out the angle? Well, it's going to be tangent because I have opposite and adjacent. So I have the tangent of alpha is the square root of 3 over 1, which is just the square root of 3. So you need to use tan inverse of the square root of 3 to get alpha. This one, you can use the unit circle. So you could look at the unit circle and you could see, when do I get the square root of 3? Or if you want to, you can do it in your calculator. If you're going to use your calculator, put the mode on degrees. But what you will end up with from doing this, I don't know, I'm writing again, but we'll go ahead and go with it since I started, is that alpha is 60 degrees. All right, let's try another one. So this one I have, I want to again find alpha, but I have the vector is 6i minus 4j. So important to think about where it is. Okay, so this is 6 over and 4 down, so we're going this way. This is where our vector is. And when we're looking at the angle, we really want to say this way. So there's going to be a little bit like two parts to this one. All right, because when we start, we're having to kind of draw this triangle, right? So we look that this is 6 over and it's negative 4 down, and we are in the fourth quadrant. So we're looking at tangent. We're going to write alpha. We'll get there. So if we call this alpha, it'll be negative 4 over 6. So that reduces to negative 2 over 3. So we're going to find tangent inverse of negative 2 over 3. And this is not something that comes from the unit circle, so you do have to use your calculator. Again, I'm going to go to degrees. I think it'll be easier if you go to degrees. So when you do that, you're going to get that alpha is negative 33.69 degrees. And you can see that it is negative 33, right? It's under, but I want the opposite one, right? I want this one that goes around. So because of that, what I'm going to do is just do 360 minus 33.69, which will give me 326.31. Watch for the homework. It should tell you how many decimal places to round to. I happen to do 2, but again, you know, we always have to watch directions. Okay, so let's turn that into a word problem. Start looking at how we can apply all this stuff that we're learning. So I have a ball is thrown with an initial speed of 30 miles per hour in a direction that makes an angle of 45 degrees with the positive x-axis. We want to express the velocity vector v in terms of I and j, and then say what is the initial speed in the horizontal direction and what is the initial speed in the vertical direction. Okay, so you go through and you're trying to grab like, what does this mean? So obviously the 45 is easy. We know that that is our alpha. And the only other thing you have is the speed, which is 30. So this would be a velocity vector. So we have our speed, and I'm going to call that the v as our vector, and I'm going to call it the magnitude, and that's going to be 30. So the question says, express the vector v in terms of I and j. So we're going to start there. V is equal to 30. We have to have cosine of 45i plus sine of 45j. So this looks a lot like one we did earlier, because earlier we found cosine of 45 square root of 2 over 2. That's still I. Sine is also square root of 2 over 2j. So I'm going to multiply. So I have the 30 times square root of 2 over 2. And this time let's go ahead and say 30 divided by 2 is 15. So I have 15 square root of 2i. I have same thing, 30 times square root of 2 over 2 is 15 square root of 2j. So we have done part 1, which says express the velocity in terms of I and j. Part 2 says what's the initial speed in the horizontal direction, what is the initial speed in the vertical. So the I is horizontal, and the j is vertical. So all you're having to do is do that. Do 15 times the square root of 2 in your calculator. This is about 21.21 miles per hour. Same thing for the vertical. They're the same in this particular situation, 21.21 miles per hour. So we've answered all the parts now. Just as a quick, here's what it looks like. Right, it's being thrown at 30 miles per hour at an angle of 45 degrees, and then breaking it into the components of horizontal and vertical, and you can see that in this picture. Okay. And now we have something called resultant force. So because forces can be represented by two vectors, two forces can combine, and that is really just the way we're going to add the vectors. So if we have F1 and F2 being forces that act at the same time on an object, then the sum F1 and F2 is the resultant force. So it says what happens when I have two forces acting on something? they combined, right? So this resultant force produces the same effect on the object that the two did individually. So it's just getting this sum here, F1 plus F2 is our resultant force. So let's look at something like that. A man pushes a wheelbarrow up an incline of 20 degrees with a force of 100 pounds. Express the force F in terms of I and J. We have this 100 pounds, which is the magnitude. And we have this 20 degrees, which is the alpha. So we are going to write our vector F as 100 cosine of 20 degrees I, parentheses in front of the cosine, then sine 20 degrees J. And then you need to grab the calculator because 20 degrees is not something that we do normally. So let's do 100 cosine of 20, and that says 93.97 I, and then I have 100 sine of 20, and that gives me 34.20 J. So we have written this in terms of I and J, and it shows the horizontal force and the vertical force that happens when this 100 pounds is pushed at an angle of 20 degrees. This one's a little bit longer, so we're finding the actual speed and direction of an aircraft. So we have a Boeing 737, maintains a constant speed of 550 miles per hour headed due south. The jet stream is 80 miles per hour in the northeasterly direction. So we want to do a bunch of things here. Express the velocity, v sub a, of the 737 relative to the air, and the velocity v sub w of the jet stream in terms of I and j. Once we have those two, we can put them together. So here's two separate forces. They're going to act together to find the velocity of the 737 relative to the ground, and then we'll find the actual speed and direction of the 737 relative to the ground. So this picture kind of shows you the airplane is traveling south, but this wind is coming northeast. So it's going to have an effect on it, right? It's going to push it some. So we have to say, what does that look like? So here's what it looks like if we put it on a coordinate system. So we have this v sub a of negative 550j because it's only going in the south direction. It's not going horizontal at all. But then v sub w is coming in at this direction here, right, where it is in the northeasterly. So it does have some direction that's both vertical and horizontal we talk about, and then together we'll get this the ground velocity to say what happened when we combine those terms. So we want to make this in small little pieces to start out. So VA is the easy one because it's only going in one direction, so that's negative 550j. That's all I have. If you look at the angle, because it is vertical, we can think about the vertical is what happens to sine there. So sine is -1, so that's where the negative is, and that's why we have the 1 there. You don't have to really put the angle in because you know it's -1. All right. And then if we look at the wind, so the wind is coming in at a speed of 80 miles per hour, and because it's northeasterly, it's right in the middle. This is 45 degrees. So we've done this over and over. Cosine of 45i, sine of 45j. So we know this is the square root of 2 over 2 I and the square root of 2 over 2 j. And we know that we can distribute and simplify. So 80 over 2 will be 40 square root of 2. And then we have again 40 square root of 2. So this is our wind. Okay. So we have VA, we have VW. So now to get the ground, we're going to add those together. Okay. So remember when we're adding vectors, we need to add components that make sense together. So I only have one I, this 40 square root of 2i. Okay. But then when I look at j's, there are two parts. There's 40 square root of 2j, and there's also a negative 550j. Probably the best thing to do is to write that as 40 square root of 2i plus, let's put parentheses, 40 square root of 2 minus 550 j. That way you have I once, you have j once. It's really just notational there, not really a big deal. Okay, so we did all of our velocities. So we've done part A, we've done part B. We're ready to go to part C, where it says, let's talk about the speed, like how fast is this going? So the speed, we're looking at the magnitude. So remember, what are we supposed to do? We do the square root of 40 square root of 2 squared plus 40 square root of 2 minus 550 squared. So you take each of the components, you square them, and then you take the square root. You don't include the I and the j, they don't matter. So throw that in your calculator. Be careful of parentheses. Make sure you have everything under the square root, and you should get something that's about 497 miles per hour. So you see that this effect of the wind coming in has slowed the ground, like it slowed down the speed in relation to the ground. So think about like the plane is pushing the gas, but the wind is slowing it down. So it's trying to go this fast and the wind just keeps pushing it a little. So that's the first part we see, is how did it push it? The next thing we want to see is, well, what did that do to the course? Like, did it push it off course at all? And if you look at the way we wrote it, the answer is yeah, it did, right? Like, yes, it pushed it off. So let's talk about how much. So I'm just going to write it again, that here is our velocity vector for the ground. So 40 square root of 2i plus we had 40 square root of 2 minus 550 j. Oops, I got the parentheses a little off. Okay, so this is in the fourth quadrant. Negative 550 is a lot bigger than 40 square root of 2. So if I pick something to be 40 square root of 2, and I pick something to be negative whatever, negative 550, 40 square root of 2, we're just coming up with some kind of like angle we think it is. Okay, so that helps us think about it. So this would be our 40 square root of 2 in the horizontal, and this will be 40 square root of 2 minus 550. That's in our vertical direction. And once again, we're finding this angle alpha to start, and then we're actually going to flip it back over to say, like, we really want to know this one right here. Okay, so we're going to have tangent of alpha as equal to 40 square root of 2 minus 550 over 40 square root of 2. So you're putting in the calculator, you're doing tangent inverse of 40 square root of 2 minus 550 over 40 square root of 2. And when you put that in, it gives you a negative 83.5. So that says this angle, right, underneath the x-axis is 83.5. So I want to know, how far did it go off course? So originally we were going due south, and now we're this much off. So I want you to think that this whole quadrant makes 90. And we're going to do 90 minus 83.5, which says 6.5. So it's 6.5 degrees off of due south. So it's 6.5 degrees east of due south. So we would say south 6.5 degrees east. I know that might be new vocabulary, right? Like, that's a different way to talk. So it's okay. Like this is why we take the time to talk about it. So if you've never heard like people talk about directions that way, you know, think back to the picture, kind of go through what are they asking for. It should prompt for the kind of answer you're supposed to give. Last little piece, we have static equilibrium. So an object is said to be in static equilibrium if the object is at rest and the sum of all the forces acting on the object is 0. So our resultant force is 0. So think static means not moving. Like, it's just nothing's happening. And sometimes you want nothing to happen. Like, that's important. So we're thinking of this idea of we want to get 0 out of whatever's going on. All right, so here is our example. A box of supplies that weighs 1,500 pounds is suspended by 2 cables attached to the ceiling as shown in the figure. What are the tensions in the 2 cables? So before we get started, it's really nice to like take this picture and put it over on a coordinate axis. So this is what it looks like. So we have 2 forces, F1 and F2, just left to right. And see how F1 instead of saying it's 45 degrees, we measure from the x-axis and we go over. So that's new, and you want to pay attention to that. So F1 has an angle that's 135, and F2, again measuring from x, is only 60. F3 is the weight, right? Here's the weight down here. So it doesn't have any horizontal, it only goes down vertically. So we're paying attention to these three things, and our idea is F1 plus F2 plus F3 is supposed to come out to be 0. So that's what we want from that. So before we can really get started, we need to kind of put together like, okay, what is F1, what is F2, what is F3? So we don't know the magnitude of F1, that's what we're looking for, but we do know the angle. So we said that this angle it was acting on was 135. So this is 135I, and then sine of 135J. So same thing, F2, we do not know that force, but we know the angle. The angle is 60, so we have 60I plus sine of 60J. And then F3, this is F3 here, we actually know F3. It's negative 1500, that was the weight, and it's J because it's only going down. So again, we could look at, when we look at F3, it's only in the vertical direction. So if we looked around, that's really 270, but we know sine of 270 is negative 1, so there's our negative 1500. So let's keep that part easy. Okay. Let's do a little bit of simplification. So we can rewrite F1 as the magnitude of F1. And then cosine of 135 is negative square root of 2 over 2. There's I. Sine is square root of 2 over 2, which is positive J. F2, same kind of deal. I don't know the magnitude, but I know cosine of 60 is a half, so it's a half of I. And sine is the square root of 3 over 2, that's a 3. J, and we still have F3 is the same. F3 is still negative 1500 J. All right, so what do we want to do? We want to gather like terms and kind of put them together. So we want to think whatever happens horizontally, those will add up to 0. What happens vertically will add up to 0. So we're back to F1 plus F2 plus F3 equals 0. Which means that our sums of the i's and the sums of the j's should each be 0, right? Like that's the only way I'm going to get 0 is if each part is 0. So with the i's, you can see I have this I here. So I have the magnitude of F1 times negative square root of 2 over 2I. And I also have the magnitude of F2 times a half, and that's equal to 0. So we could take this, right, just this piece, and do a little rearrangement. So what I'm going to do, because this part is negative, let's move it over to the right. I'm going to put the 1/2 in front of the magnitude of F2 and say that's equal to negative the square root of 2 over 2 times the magnitude of F1. To get rid of this 1/2, I'm just going to multiply by 2, which shows I multiply this also by 2. Now I have that the magnitude of F2 is equal to negative the square root of 2 times the magnitude of F1. So we don't exactly know any answer, but this is going to be helpful. So we kind of want to hold on to that and say, oh, here's something that we know. Let's see if I can put something in here. We'll end up going to the next page. So we also have to worry about, okay, we looked at the i's. Let's look at the j's. So I kind of didn't write the i's here, but this is coming from the i's because I went through the i's. That's what I knew. So if I look at the j's, so what I have for the j's, well, I have this square root of 2 over 2j. Well, let's not write the j. Let's just write magnitude of F1. So I'm going from this one. So I have the square root of 2 over 2 times F1. And I also have the square root of 3 over 2 times F2. And I have minus 1500 from F3, and that should be 0. So let's go ahead and write that on the next page. So square root of 2 over 2 f1, square root of 3 over 2 f2, minus 1500. That's supposed to be 0. But what did we just find out? So in our last little part, we found out that f2 is equal to f1 times the square root of 2. So I'm going to substitute that right here. So I'm going to have the square root of 2 over 2 f1 plus the square root of 3 over 2 times the square root of 2 times the magnitude of f1. And then I'm just going to move this 1500 over. So it's 1500. So here, I just took the magnitude of f1 out, so I have the square root of 2 over 2. I have the square root of 3 over 2 times the square root of 2, and this is 1500. I can simplify that just slightly. I can make this the square root of 2 over 2 plus square root of 6 over 2, and that's 1500. So to get the magnitude of f1, I'm going to take 1500 and divide by the square root of 2 over 2 plus the square root of 6 over 2. If you're putting this in like a regular handheld calculator, you need parentheses in the denominator. If you have Desmos or something, then you don't, because you can visually see that it's in the right place. But with handheld, parentheses are important. Put that in the calculator. It gives you about 776.5 pounds. So this is the magnitude of F1. Similar to that, because remember we have this statement that F2 is the magnitude of F1 times the square root of 2. So this says F2, the magnitude, I do the square root of 2 times 776.5, and we get 1,098.1 pounds, right? So this says, like, let's go back and look at our picture. So in our picture, our F2, this force on this one on the right was 1,098.1 pounds. And then the force on the left was 776.5 pounds. So these two, right, tensions together are holding that 1,500 pounds in place. So that's what we found out by doing this. Right? I know that's a big problem. I know that's going to take you a while. That's why I made you this video. I want you to kind of look at the little pieces, write everything down before you try to put it all in like to the answers when you're doing the homework. So I hope that helps. I know that's a long one, but I hope you also look at it and go, oh, that's awesome. I see how this relates to the real world. And definitely, if you're taking physics one day, vectors is something you will see again.